Welcome to our session today, Talk to Your Dashboards, where we talk about using Model Context Protocol and large language models to simplify observability. So before we get started, we'll take a moment to introduce ourselves. I'm Prashant. I'm a machine learning engineer at Apple. My focus areas are observability, machine learning, and natural language processing.
Hi, I'm Raj. I'm also a machine learning engineer at Apple. I work with the observability team, and my background is also in observability, machine learning, and data science.
So let's start with what the session is really about, demystifying how we work with our observability systems. So today, our monitoring stacks are incredibly powerful, but they are also fairly complex. So in this talk, we'll focus on what is Model Context Protocol and why it matters, how we can make observability more accessible using natural language, how to make different tools work together, cross-platform interoperability, and finally, how we can add guardrails for safe automation. So this talk is for anyone who's managing observability systems or monitoring pipelines, or basically anyone who's ever said, why my dashboards are not working again. So to talk about this, we thought it'd be interesting to take a scenario where you're responsible for a lot of critical systems which emit a lot of data, and where not having observability can be catastrophic. So let's imagine we're running a mission control for a space program. So we have got 6 satellites, 3 rovers, and 100 engineers who are monitoring power, communication, battery life across countless dashboards at any given time. So every spacecraft has its own signal, its own dashboards, panels, and its own quirks. So instead of analyzing the mission, we often spend half of our day trying to figure out which dashboard even has the right query. And this is where observability can start to cost in engineering hours, alert fatigue, and slow incident responses. So let's zoom into these satellites. Now, every satellite emits its own data. That's like power, battery, altitude, latency, and a lot more. And in observability terms, these are our metrics, traces, and logs. So each operator then builds their own dashboard, panels, queries, and alerts around these metrics. Now, this is how observability often works in distributed environments. If each new mission means new data, new visualizations, new configs, it also means new potential breaking points. And this is how things can get a little frustrating as well. As systems change and evolve, that leads to something breaking, which leads to a dashboard failure. There, engineers panic, they investigate, they patch YAML files, redeploy dashboards, test queries, and apply manual fixes. Now, things are okay for a while, and then something else breaks again. It's a never-ending loop, and the result is lost time, context switching, and growing operational debt. And the reason it has become so complex today is observability today is fragmented by design. We have Grafana, Perses for dashboards, Prometheus, Cortex for metrics, Jaeger for traces, OpenSearch for logs, and a lot more. Now, each tool is incredible on its own, but they all store, query, authenticate differently. There's a JSON here, YAML there, CRD somewhere else. And these differences can make integration brittle. So observability silos often slow down insight and automation. And now let's imagine if you could skip all of that manual work. So if your dashboard breaks, instead of deep diving into JSON or YAML or PromQL, you just say, hey, fix my satellite dashboard. And the system understands your intent. It finds the failing panel, the query, identifies the metric name, updates the dashboard automatically. So there's no context switching, there's no YAML deep diving, just natural language. And that's the vision, moving from configuration to conversation. Now, Raj will tell us how we can achieve that vision today.
Thank you, Prashant. So how do we make that vision real? Ideally, we want an observability agent that acts as a co-pilot and can do the investigation, the manual work, and the fixes for us. And today, we can do some of that. Now, let's look under the hood of how we can use this observability agent today. The agent connects 3 things: observability data, which is logs, metrics, and traces emitted from our satellites; LLMs, which provides reasoning and understanding and makes sense of all the space data; and actions, which involves insights, anomalies, summaries, even fixes that our space mission control specialists can use. So this agent just doesn't respond, it reasons. It understands context, identifies what went wrong, and acts. So how did LLMs evolve into these agents? Large language models began as brilliant text generators. They could summarize information, write your incident reports, and help us reason. But they could not act. Over time, LLMs evolved. They learned to call functions, use APIs, and handle structured output, bridging human intent and machine execution. Then came agents, which are LLMs with memory, planning, and tool use, systems that could take action and close the loop. Now with agents, our observability landscape starts looking something like this. Each of our satellites streams logs, metrics, and traces into different systems. But to the astronaut or the operations team, all these systems and data are still fragmented. And that's where the agent comes in. It becomes the bridge. It connects to all these sources and translates them into unified understanding. Because at scale, observability needs GenAI, and GenAI needs observability. That's the power of connecting context. Faster insight without engineers manually stitching data together. But here's the pain. Even though our agent connects all these observability systems, each one speaks its own language. When our astronaut asks the agent for something simple, like the current power status of a satellite, the agent has to query multiple systems, each using its own schema, protocol, and authentication method. If any one of those fails, an expired token, a mismatched schema, or a changed endpoint, the request breaks silently, and the mission operator just sees no data. This is the hidden cost of AI-driven observability. Compute and token usage are predictable, but integration fragility is not. Every connection becomes a new custom job, and every new data source means another brittle adapter to maintain. That's why we need a shared, standardized way for systems and agents to communicate, one that's reliable, bidirectional, and context-aware. And enter MCP, or Model Context Protocol, which is an open standard that defines how LLMs and agents interact with external systems. So instead of writing custom adapters for every API, we connect once through a common protocol. Think of it as the observability equivalent of USB. Plug in any MCP-compatible tool, and your AI agent just knows how to talk to it. It replaces API sprawl with a single shared language. Here's how it works in practice. Each observability tool or systems connect to an MCP server. The MCP client sits alongside the agent, handling connection, schema discovery, and streaming responses. This setup allows the agent to reason in natural language, but act in machine precision. Now, let's zoom in on the MCP server, which turns raw APIs into something the model can understand. It exposes tools, resources, and schemas, all self-described and discoverable. So the LLM just doesn't see endpoints, it also sees the meaning behind them. The server handles authentication, context, and two lightweight communication modes, SSE for real-time and standard IO for local or offline uses. The key difference between traditional APIs is that this setup is bidirectional and introspectable, meaning the client can discover capabilities dynamically instead of relying on static documentation or SDKs. And there is also an added bonus, where MCP servers can cut down on token usage. The model only exchanges concise summaries, not full data payloads. So in short, MCP servers make APIs understandable, efficient, and model-friendly. Now that we have covered how servers expose capabilities, let's move to the MCP client, which manages reasoning, streaming, and execution. Now the MCP client is where reasoning turns into action. The server defines what's possible, the client decides how to use it. It translates the LLM's intent into structured JSON RPC requests, handles streaming and authentication, and ensures execution is schema safe. You can think of it as the interpreter between languages and systems. It ensures precision, while the LLM focuses on reasoning. Open source clients already exist today, like MCP Python, TypeScript SDKs, and many more. making it easy to build your own integrations and agents. Together, servers and clients make up the connective tissue between observability tools and LLM reasoning, a clean, efficient bridge. So while the server standardizes capability, the client standardizes execution, enabling agents that are smart, safe, and a little more cost efficient. So why does this all matter? Because it changes how we work, especially when time is critical. Imagine you are in the middle of a mission update and something looks off. Traditionally, you would be buried in JSON files or dashboard configs, flipping through documentation like you are in a Houston, we have a problem moment. But with natural language and MCP, you can just ask, show me power anomalies of for Apollo in last 48 hours. The agent figures out which systems to query, correlates the data, and gives you the answer fast. The real win here is accessibility. Anyone on the team, not just the experts of observability system, can get answers when seconds matter. Of course, this doesn't mean we throw it everywhere. Running LLMs at scale isn't cheap, so it makes the most sense for high-value, time-sensitive systems like satellite telemetry or production reliability. But for smaller organizations or less time-sensitive scenarios, lightweight open-source LLMs and MCP clients can still deliver 80% of the benefit without the additional heavy cost. So this isn't about using AI for everything. It's about freeing engineers from the low-level work and focusing on what really matters, decisions. Now, let's look at how to set up MCP servers with your MCP clients. On the screen, you can see configurations for both Perses and Grafana. So these configurations are client agnostic, meaning you can use them with any MCP-enabled tool. For Perses, you will specify the command, which points to your MCP server binary, along with the URL of your Perses instance and authentication token. The Grafana setup is similar. You provide the Grafana instance URL and the service account token. Next, let's see where you can get the Perses MCP server and the token you'll need. You can download the Perses MCP server binary directly from the project's GitHub repository. You'll also find builds for other operating systems there. The documentation also explains how to generate a Perses authentication token using the CLI. Once you log in using Perse CLI and run show token command, you'll have the token ready to add in your configuration. Also, these are the Slack channel and GitHub links to Perses. It's a pretty cool project. Do check it out. Once you have downloaded the binaries and gathered the tokens, you can add everything into your MCP client configuration. And here's what a final combined setup looks like. So both Perses and Grafana MCP servers connected to a single agent, a single client. This configuration allows the agents or LLMs to interact with multiple dashboards seamlessly, from fetching metrics to automating updates. And with that, I'll hand it back to Prashant to show how this all comes together in action.
All right, thank you, Raj. Okay, so now Raj has covered what MCPs are, how to add them. We can come back to our cool space mission control and see what we can do with them. So let's assume, we'll take a couple of use cases. So let's assume one of our satellites, Voyager, gets a firmware update. It's a minor update, but during that firmware update, a metric gets renamed from satellite power output watt to satellite power output watts. Now, it's a minor change, but what happens next? The dashboards go dark. You see unknown metric, no data, alerts are firing. And suddenly, mission control loses visibility on Voyager's power output. Now, is something wrong with the satellite? Is Voyager losing power? Or is it an issue with our data? So often when changes are this small, they can easily be overlooked because of human error as well. Now, every hour of lost visibility means missed SLAs, delayed decisions, and potential downtime. That is also the hidden cost of complexity. So, and it's more evident when you're accounting for the time of highly skilled mission specialists. And let's look at another angle for this use case, when we are querying our dashboards in the middle of a signal storm, and you don't have the entire context. So imagine you are the astronaut on the International Space Station and managing multiple satellites. Now, each one of them is streaming countless metrics back to Earth: power, communication latency, solar efficiency. but you have to be aware of every part of this complex machine. But when something goes wrong, let's say you're noticing a temperature drop in one of the satellites, and mission control isn't available, do you really want to sift through hundreds of dashboards to find that one metric, or would you rather have that information at your fingertips? So in our demo, we'll showcase some of these use cases where we create projects and dashboards. We showcase conversational dashboard interoperability, adding visualizations, do root cause analysis, and querying our dashboards all through natural language. So now let's see how we can use MCP servers to manage our dashboard and address these use cases. Now, we first start by seeing what tools are available with Perses. Apart from getting all of the information on tools and the description, it also serves as a sanity check on whether or not we can connect to the server via client. So, as you see here, we are getting all of the tools for dashboard management, projects, data source, variable management, RBAC, and plugin. All right, that's great. Now, we'll start by creating a project called Mission in Perses. This is where we do all of our operations for the demo. The agent just told us it created the project, and we check Perses. The project has been created. Now, the Perses MCP server doesn't have a tool call for creating a project-level data source, so we create one via UI called Prometheus data source. It does have a tool calls for creating global data sources and listing project-level data source, but we do this via the UI. And now for the fun part. Let's create a dashboard with some of the metrics where we track satellite power, battery, and latency for a satellite Voyager. Now, if you see here, I specifically called out which data source to use because MCP servers need a bit of TLC sometimes. It eventually figures it out, but it's just a lot of back and forth, which can eat up your tokens and context quickly. So it looks for creating the specific project, data source, and it creates the dashboard for us. And when we check Perses, the dashboard has been created. And we can see the queries as well. Now, this is great, but this is, in the end, a static dashboard. We are mission control. We want flexibility. So we'll start by creating a variable that we can use in our project. So we'll create a variable called satellite ID, where we can update and create a default value Voyager and description. Now, in this response, you will see that the Perses MCP server calls out that it can create the variable for you, but the schema doesn't allow setting a default value or the description. So that's also schema validation that we will talk about. So that's no big deal. We see the variable has been created, and when we check, it hasn't created the default value Voyager. It just renames the actual name. Okay. So we set the default value as Voyager, and now we ask our agent to create a new dashboard, satellite control v2, with the same queries. And you'll notice that we didn't specifically call out the PromQL expressions in this time because the agent has that context, or if it doesn't, it can get it from the dashboard. So now it creates the new dashboard for us. And we see the new dashboard has been created, satellite control v2. The queries have been updated, and on the top left, you can see the variable as well. If we update it from Voyager to Apollo, you see the panels update automatically. All right, so now we just saw how easy it was to create dashboards and panels dynamically through Perses MCP server. But in a large organization, not everyone is using the same observability or visualization stack. So we want to ensure that some people use Perses, some people use Grafana, Chronosphere, and so on. We want platform interoperability because, first of all, rebuilding dashboards manually can be really tedious, and no one is expected to know every visualization stack by heart. So let's see what we can do about that. We ask our agent to create the same dashboard in Grafana. Here, the agent checks what data sources and what projects are available in Grafana. It lists the data sources. It lists the folders. And it creates a folder called mission to replicate what we have in Perses today. After that, once it has created the folder, it creates the satellite control V2 dashboard in Grafana for us as well. And as you see here, it has created the new dashboard for us in Grafana. It has the folder and the dashboard. Now, let's see if we can take it a step further. Instead of asking our agent just to migrate the dashboard, let's see if we can ask it to enhance it. So we ask it to create a new panel that compares power versus battery. And here, again, we do not provide any PromQL expression. The MCP server checks a dashboard config, finds the queries. We also ask it to create appropriate legends. So it should be able to decide what legends to use for a new panel. There you go. A new panel has been created, and if you notice, it has set up custom legends on the y-axis, along with extra information like min, max, mean. Now, let's see if we can push our system further. If you remember initial use cases, we'll simulate a misconfiguration of the satellite power that we talked about. So we'll create a new visualization and input the incorrect metric name. And as you can see here, with the visualization, I don't see any data. And then we ask our agent to just fix our observability dashboard. Now here, it gets the dashboard config, identifies the panel with missing data. Because it has the context, it checks what is the correct metric query, and then it fixes the dashboard for us as well. Over here, it's saying the changes have been applied. And if you refresh, the panel has the dashboard now. But that's not all. We also want to see what would happen if we can ask it to, so I just want to check. Yeah, so now the second use case was when we want to query our dashboard. So let's see if we can ask it information from our panels. We want to get the satellite power from our dashboard. So it looks at a dashboard config, it queries the Prometheus metric for satellite power, it goes a step further and gets us information for every metric that is being seen in a dashboard right now, and provides that information in natural language. Now, in all of these cases, it already had the context of what the PromQL query was. So in case if we ask it about an entirely new information like payload temperature, something it doesn't really have the context for, let's see what it does. So first, it queries our payload temperature metric from Voyager satellite. It doesn't find it. So it finds any temperature-related metric to see what's available. And then it checks what metrics are available for Voyager satellite. And eventually, it tries to find all the available metrics for what's being collected. And then it actually finds the right metric for us. This is great, but it's also a limited way to use this because it will eventually eat up your context really quickly if you have a lot of metrics, which, let's face it, almost everyone does if you're working for an organization. But as you see here, it found the actual metric for us, and it provided the payload temperature. So in mission control, every second matters, and so does every insight. And honestly, this demo took me around 20 minutes to make. I mean, this version of the demo, there were a few previous versions. But now imagine doing the same thing manually, where you're digging through JSON, editing dashboard configs, trying to fix queries in a visualization stack that you're not really familiar with. This would have easily taken me hours or more. So with Model Context Protocol, we connected our LLMs to our observability stack, creating, fixing, and enhancing our dashboards, all with natural language. And I hope this demo showed how powerful this can actually be. But with great power, it also comes the need for guardrails. Because when you give an agent control over dashboards, alerts, and configs, even a simple natural language command can be powerful, but risky. So how do we keep it safe? The first layer is policy and role-based access control, the basics. An agent shouldn't be able to delete or modify your dashboard without express approval or be able to do it within your assigned permissions. The second layer is validation in the MCP client. This is where we make sure that the tool input matches your schema, limit the scope to approved projects, and also possibly do dry runs before real execution. And then we finally add the third layer, which is on the server side. Full audit trails for every natural language action. We log before and after diffs. We support rollback and track exactly what has changed, when, and why. The beauty of MCPs and LLMs is that it gives you flexibility. But it's these layers that make it safe to use in production. So as you move towards autonomous observability, these kind of controls ensure that the AI isn't just smart, but also trustworthy. So to wrap it up, a few key takeaways from this journey. First, observability isn't just about collecting data, it's also about connecting it. When your data works together, you get context, and that's when real insight happens. Second, natural language changes how we interact with the systems. Whether you're in mission control or SRE war room, just being able to ask your system what's happening makes observability a lot more accessible for everyone. Then flexibility only works when it's safe. Guardrails like RBAC, validation, and audit trails keep the system trustworthy and production ready. And finally, the future of observability is collaborative. MCPs and LLMs give us a better way to understand and act faster. So if you like the talk, please rate us. And if you have any questions, please go ahead. Thank you.
Amazing presentation. I'm just curious if once you have those dashboards set up, would it be possible to then find anomalies that I'm looking for in that dashboard and then kind of figure out in the system, maybe the Grafana anomaly in Grafana dashboard is somehow connected to a logging anomaly in my system, and I can figure those two out and have it in the conversational mode.
So,
is that something possible with Perses?
So Perses is still a newer project. So a lot of the tool calls there are still in development. In Grafana, you do have a few alert tools, but your main question, I think, stems from if you can connect our different observability modalities together, which you can, but you'll still eventually have to have an anomaly detection framework in place to identify what the anomalies are. Yeah, thank you. Thank you. Yeah. I'll upload it and it should be available on our talk. Yeah. Thank you.
Yeah, hi.
Hi.
I have a question on how are you guys using this on your day-to-day over in Apple and how far you've taken this?
Well, we'd like to keep this on open source, but mainly, as you see here, this is a really accessible way to use this, use observability stacks. So that's exactly what we want to just present here.
Okay.
Thank you.
Are all your developers using that? And is there like an overwhelming amount of dashboards just on Grafana or your Perseus that...
I'm not sure what everyone is using there. This was more in terms of just an open source work that we wanted to showcase.
Okay.
And we wanted to mainly showcase like the Perses work, working with an observability stack that we're not familiar with.
Okay, and then what's next in the pipeline for this project?
There are a lot of new things that are happening. There is now agent context protocol, multi-agent frameworks that are being developed. So that's something I'm personally looking at. Thank you.
Cool. Thank you very much.
Awesome. Thank you.
Question, curious if you have experience using exemplars with OpenTelemetry with MCP and cross systems, how has that worked, or what exemplars did you use?
Do you want to take that?
Sorry, I didn't get the question. Actually, I could not hear.
For exemplars with OpenTelemetry, what exemplars have you used as part of your work with MCPs, or what do you recommend?
So in this talk, we didn't really use any exemplars, and we have looked at exemplars mainly to connect with metrics and traces, and that's all we have tried using.
Okay,
Yeah.
so not with MCP specifically,
Not
though.
with MCPs now.
Yeah.
Thank you.
Really great talk, guys. I
you.
had a question about collecting context about your telemetry. So I think in your example, you showed when there's not enough context, it goes through a bunch of hops where it needs to check this, check that, and then eventually it figures out this is the actual metric I care about. Now, do you have any recommendations or solutions for fine-tuning generation of that context?
So you can first of all, use better context. I was purposely using like really vague expressions like, hey, fix my dashboard. Because I was working with like, a very limited amount of metrics that I had set up. There are two things you can do. You can set up context for your agent so that you know which data source to use. You can also use better prompts than what I was using. That's like the surefire way to get ahead of, just making it go in a loop.
Yeah.
Gotcha. Thank you so much.
Thank you.
Thank you.
I think we are done.
Hey. Hoping,
Hi.
Oh, hi.
hey. Hoping to be no redundant. What's the framework you use to build up the agent?
So in this, we were using an available agent, but there are open source implementations like LangGraph, and there's one other, right?
K-agent. So I think under CNCF there is also a project called K-agent you can use to build agentic frameworks. So I think I did mention the logo, but I think that's also something you can explore and use it for your use case. Yeah.
Okay. Thank you.
Thank you.
Hey, it's a good demo. I just have a question. First of all, thanks for this wonderful demo. Regarding that MCP servers part, are you guys using the open source MCP server, and how you are maintaining it? Like where you installed that server?
So yeah, I think for in this demo and also like we have shown all those tools, right? Prometheus, Grafana, Perses, they all have open source MCP servers. So yeah, those are the open source versions that we have used for the demo purposes as well. So yeah, it's all open source. I think the open source ones only. Yeah, the link that I shared, I think for the GitHub on Perses, that has the repos and projects for MCPs and how to use that. So yeah, those are the ones that we have.
Okay. So are you started using it in real time? These like licensed versions or anything?
Sorry?
Have you used the real time this MCP servers in your projects? Have you used it?
Can you define what you mean by real time? Like, are you talking about production workloads?
Yeah, production. Yeah.
Again, so this is something that we were doing on our own time. I can't speak for like what is being done in production at Apple.
Okay, sounds good. Thank you.
Yeah.
Hi, how are you guys? I'm Larry from Workday. So I work in the observability kind of area. I'm an observability engineer. So I'm thinking also to bring this agentic workflow and MCP kind of context into our observability stack. So my question is about how do you implement this guardrail or make it safe? More specifically, what kind of identity kind of provider you integrate with this stack? For example, do you use AD kind of group control or LDAP or whatever to control this, to implement this role-based control and make it safe to use?
So apart from like the authentication tokens that we were talking about, which are part of your MCP server stack itself, that's how you can implement role-based access control. You can also add guardrails in your prompt or post validation steps where you can make sure your MCP client doesn't access projects or always ask for permissions for critical operations like modifying your dashboard or deleting your dashboards. So I know Perses MCP server and Grafana MCP server don't really have tools for deleting your dashboards, which is, I'm assuming, by design.
Right.
But you have to ensure that apart from having access to these MCP servers, you can limit it through your, the token that we showed earlier.
Okay.
You can also ensure that you have to explicitly ask for permissions. You can add those through your prompt guardrails itself, or you can also provide that context if you're using agentic frameworks.
So I see. So you're integrated with the JAW tokens, the JWT tokens, or some sort of tokens to make sure the user has a specific role before
Exactly.
they perform certain action, right?
Yeah.
The service account tokens that we were talking about earlier, you can set who has access to what.
Yeah. So that you can make access control based, yeah. The token that you generate from Perses.
Okay.
Yeah.
All right. Thank you.
Thank you.
Yeah, just a quick question regarding the time frame. You mentioned it took you 20 minutes to build the demo. I'm curious to know how long it took you to build the low-level tools to make the agent work.
The tools, like the metrics and everything, an hour, 2 hours max. Yeah.
Yeah.
Okay.
Thank you.
It was a POC. Thank you.
Hi, I just have one question. First time KubeCon. How did you guys get so awesome? Were you guys born that way? Or was this like an over time you grew to be that awesome? I'm just curious.
Learn behavior.
Yeah.
Okay, just thank you. Thank you for your time.
Awesome. Thank you.